Welcome back, sports fans, and here we are again. What we're going to be talking about today is using algebra and trig identities to solve different expressions. You know, we did some quadratics, and you're going to have, instead of just like x squared plus 5x equals 13, you're going to have sine squared plus 5 times sine equals 13. And we're also going to be able to make substitutions in that. So if you can do your algebra, you can do this stuff. And the only difference is that you're going to have, it's going to look ugly. But, you know, ugly things need love too. So let's go into this first algebra review. Multiply and simplify. I'm trying to review with you that the difference of squares. When you see x minus y times x plus y, I'm hoping that you know that's x squared minus y squared. When I have something outside the parentheses, I have to multiply it times both terms, and terms are separated by a plus or a minus inside the parentheses. So we take 5x times x, and then the 5x times the 3. So you get 5x squared plus 15x. X plus y squared. This is a very common mistake. A lot of people want to put x squared plus y squared. They forget about the middle child. This x plus y quantity squared means x plus y times x plus y. So it's actually x squared plus 2xy plus y squared. Don't forget about the middle child. You need that 2xy in the middle. To do number 4, that's just foiling first terms, outer terms, inner terms, and last terms. It's the same as saying take 3x times both of these guys, and you take the 1 times both of these guys. So you end up with 6x squared minus 15xy, that's the 3 times the minus 5, plus 2x, that's the inner term, and minus 5y, that's 1 times the minus 5y. There are no like terms, so that's it. Factor and simplify. So once once you learned how to multiply in algebra, they have you go backwards, and you say, okay, xy plus x squared has a common factor of x. So I take x and I open the parenthesis, and then I say x times what would give me xy, that's going to be a y. X times what gives me x squared, that's an x. X squared minus y squared, that's the reverse of number 1. You just need to know it. X plus y times x minus y. When I see something like number 7, 4x squared, 8x, 4, they have a common factor of 4. You need to factor that guy out first before you factor the inside. So I'd have 4 times x squared plus 2x plus 1, and that should look similar to number 3, x squared plus 2x plus 1. So when you see this, it's the same as 4 times x plus 1 times x plus 1, but I could write that shortly as 4 times the quantity x plus 1 squared. These you may not have had a lot of practice with. I have a numerator that's x squared minus 2x minus 8, and a denominator of x minus 4. What most students would like to do is take this x and cancel it with the x up here, and take the 4 into the 8 and say that's 2. That is very, very, very wrong. Do not do this. This is horrible. You can only cancel factors in fractions. You cannot cancel sums. So you have to factor it first. So the numerator would factor as to x plus 2 times x minus 4. That's factoring the top. And then it's just x minus 4 on the bottom. Now, since I have something times something else, I can cancel out x minus 4 and x minus 4. Slash and burn. I love slashing and burning. So the x minus 4s are going to cancel out, and that's just going to leave me x plus 2. Bada boom, bada bing. What is nice, I love the slashing. The slashing is so much fun. It is getting close to Halloween, you know. Alright, when you involve trig functions, you may also be able to use identities to make substitutions in order to simplify your expression. I think you guys have already caught on to this, but sine squared x actually means sine x quantity squared. So when I see tangent squared x minus cotangent x, they want you to factor and simplify. You might not be able to simplify, but I know I can factor it. So this is just like a difference of squares, a squared minus b squared. So I'd have, instead of an a, I've got a tangent. Instead of a b, I've got a cotangent. So I can do that. Instead of a plus b, it'd be tan x plus cotex, and then tan x minus cotex. I know what you're thinking. I'm not going there. That's the difference of squares, and that's how you'd write it. Is it ugly? Yes. But like I said, it needs love too. To simplify this other one, I hope you remember from the homework, when we had the pi minus theta, we graphed those to see which graph it looked like. Was it sine, cosine, negative cosine? In this case, when you graph that one, it looks like negative cosine. So we would have just cotangent theta minus a negative cosine theta. That's cotangent theta plus cosine theta, and that's my final answer. I really can't simplify it any further than that. Now, number 3, 4 times sine x squared, sine squared x plus 8 sine x plus 4. This one should look familiar. It's in this kind of format. If sine x was an a, it would look just like this. And if you know how to factor this, you know how to factor this long one. Is it going to look ugly? Yes, it is. If we factor out the 4, you'd have sine squared plus 2 sine plus 1. And this factors, as you know, as sine x plus 1 times sine x plus 1. Or you can write it as 4 times sine x plus 1 quantity squared. If somehow you can get in your brain that the whole big like sine x is just like one letter, I think you'll catch on to it pretty quick. Let's do some more slashing and burning. Oh, yes. So this first one, I've got 30 sine cubed x cosine of x over 6 cosine of x, and it's all a product, top and bottom, so we can definitely slash and burn. I'm going to separate things just so that you can see. 30 is the same as 6 times 5. You got your cube, you got your cosecs and your cosecs. 6's, slash them. Cosecs, gone. And all I'm left with is 5 times sine cubed x. Number 5, can I just cancel the sine x and sine x? No! Don't do it. Do not do that. You have to factor first. Lots of F's. So, if you don't factor first, you will get an F. Sine x squared plus 2 sine x plus 1. We've already seen that factor. Sine plus 1, sine plus 1. And then the denominator was sine x plus 1. Now you can slash and burn because it's this guy times this guy. Rink, rink, they're gone. He gone. So then all I'm left with is sine x plus 1. By the way, extra credit tomorrow. He gone. What show is that from? I'll give you 2 bonus points if you can tell me. Now, number 6, I have a difference of squares in the numerator. I cannot cancel the signs because, like I said, it's got to be factored. This is a difference of squares. Just like if it was x squared minus 1, you'd do x plus 1, x minus 1. So this is going to be sine plus 1, sine minus 1. Now I can slash those 2. He gone. I love that. Anyhow. So I think that pretty well you end up with just sine theta minus 1. Let's do another one where it says factor and simplify, or simplify the expression. The trouble most students have is knowing when they're finished with this. If you start getting more complicated, that's not making it simplified. Simplify means make it as short as possible. When I see I have cotangent of x times sine of x plus x, then what I need to do is figure out how I can simplify that. One trick that I like to use, not a trick, but is to put things in terms of sine and cosine. So if I multiply through the parentheses, I get cotangent of x times sine of x plus cotangent of x times secant of x. It doesn't look like it would simplify anymore, but if I put everything in terms of sine and cosine, something might cancel. So I'm going to say cotangent is cosine over sine, and replace those two. And secant of x is 1 over cos. Now I can slash. When I say cosine over sine, cosine divided by sine times sine, those are going to cancel out. And the cosine up here is going to cancel with the cosine down here. So the numerator and denominator cancel. And I am left with cosine of x plus 1 over sine of x. This one can be written a little more simply. 1 over sine of x. Hopefully you know that is cosecant. So now I am finished. I am simplified. And you can see this is much shorter than what I started with. And as I went down, right here I made it a little more complicated with more stuff in it, but that was just to get things to shake out, to cancel out. It doesn't also matter if you put things in terms of sine and cosine before you multiply or after. Sometimes you can do that first and it's easy to multiply through. Let's look at this one. This is a little different. Tanny sine times coti minus cosecant. So these guys, I see right away, I should recognize, hopefully you recognize that tangent and cotangent are reciprocals. So when I multiply those are going to cancel out themselves. And sine is a reciprocal of cosecant, so that one's going to cancel out. So I started out, instead of putting things in terms of sine and cosine, this cotangent, I wrote it as 1 over tangent, because I know when I multiply through here, that's going to cancel. Cosecant is 1 over sine, which will cancel with this part of the product. When I multiply through here, tanny sine times 1 over tanny, the tangent part cancels out, and all you're going to be left with is the sine. So that's going to be sine y. When I take the tanny sine times 1 over sine, the 1 over sine cancels the sine part of that product. So I'm just going to be left with tangent. So that's the final answer there. I wanted to do some additional examples just to kind of get you ready for the homework, and that's what you're going to be doing. Let's do another one. Sine theta plus cosine theta quantity squared. Multiply that sucker out. It's not sine squared plus cosine squared. Don't forget the middle child. It's going to be sine squared plus 2 cosine plus cosine squared. If I notice my Pythagorean identities, when I see the squared things, that can be replaced with something much simpler, namely the number 1. Sine squared plus cosine squared is 1. And you'll have plus 2 cosine theta sine theta. That's it. Try this one on your own. Sine x plus cosine of x times secant of x plus cosecant of x. I would recommend that you put things in terms of sine and cosine to begin with. So sine x plus cosine of x, I end up with 1 over cosine of x, 1 over sine of x. FOIL it out. First, when I take sine x times 1 over cosine of x, I get this guy. Cosine times 1 over cosine is 1. Sine times 1 over sine is 1. And cosine times 1 over sine ends up to be cosine sine over x. So I end up with tangent of x plus 2 plus cotangent of x. I'm hoping you paused that and tried it on your own. Okay, we're going to hit part 2 tomorrow. Good luck, and I will see you later.